Hey everybody, so your first video for this unit is going to be a little bit longer, so be prepared, and you need your calculator. So please make sure that you have your graphing calculator, and when you grab your graphing calculator, please make sure that you check to make sure it's in radian mode. Alright, those of you who are in physics are probably in degree mode, so always, always, always be in radian mode for calculus. Okay? Alright, so the first thing we're going to talk about is storing a function in your calculator. We haven't done a ton of work with the calculator, so that's why I really want to make sure you understand how to do this right now. So if you look at these two functions, they're the same for finding a derivative and for finding an integral. And the reason we're doing that is because I want you to be able to store it in your calculator and not have to push as many buttons to actually find the derivatives and the integrals. So the first thing you're going to do is go to y equals and actually type in the function as if you were going to graph it. So y equals 10 plus 0.8x times the sine of x cubed over 100. So make sure that you wrote it exactly as it's written on your paper. If you write it once really well, then you don't have to write it every single time you do something with that function. Alright? So make sure that it's in there and we're good to go. Okay. Now we're going to find a derivative. So we're going to find f prime of 7. So hopefully you remember, I know it's been a while, but to find a derivative with your calculator, you can hit the math button and go down to option 8. It actually even says n derive, right? It's taking the derivative. So you can just hit math 8, but I showed it to you. So we're going to take the derivative with respect to x. We're going to take the derivative at x equals 7. So the part in here is where we have to put our function. You could, if you want, just type the function again, as long as you type it correctly, but sometimes they get really complicated. So we don't want to have to always retype them. So what we can do then is if we actually hit this button right here, it says vars, right? It stands for variables. So hit that button, and we typed our function into y equals. So we're going to go to the y variables part here. And we typed in a function, so we're going to go ahead and hit enter. And there's the list of all the functions from y equals. We typed ours into y1, so we're just going to go ahead and hit enter. And so what this is going to do is it's going to take the derivative of the function that we put into y1, and it's going to take the derivative at 7. So just go ahead and hit enter. So we can see that f prime of 7 then is equal to, we want 3 decimal places, so we're going to do negative 8.1, and we're going to round that up to 20. Okay? Now we're going to find an integral using our calculator. So hopefully that one's a little bit more fresh. So Math 9 gives us an integral. We're going to do the integral from 0 to 2. And again, we need to get that y1 in here. So we're going to hit the variables button. We know that it was a y variable, it was a function, and it was y1. Okay? And then we're going to take that with respect to x, right? It's the integral of f of x dx. So there we go, and hit enter. So the integral from 0 to 2 of f of t dt is equal to 20.051. All right, moving on. Before we can really dive into talking about average value, we need to talk about interpreting the meaning of your answer. So you're asked to do this a lot. You've been asked to do it with derivatives, you've been asked to do it with integrals, and then coming up you're going to be asked to do it with average values. And so you have to know how to write your answer. So the first thing you are always going to include in your interpretation of your answer is a noun. It's the thing that you're actually finding. Alright, the next thing that you're always going to include are your units for what the noun is that you actually found. And then the last thing that you are going to do is you are going to talk about the time. When are you finding this thing? Okay, so if we scroll down, I actually already wrote in the explanation of what this is. I'm going to talk about it briefly, but I wanted to make the video a little bit shorter. So we're trying to find h prime of 4 in the context of this problem. So h of t represents the height of the tree in meters. We're trying to find h prime of 4. So maybe make a note and remind yourself that h prime of 4 means you're finding a derivative, which is a rate of change. All right, and so when we write our explanation, h prime of 4 represents, here's your noun, it's the rate the height of the tree is changing. That's the thing that we're finding when we do h prime of 4. All right, and then what are we measuring it in? We're measuring it, in meters per year. There's your units. And then we want to talk about when are we doing it? Well, we're doing it at time t equals 4 years. So those are the three things that always have to be here: the noun, the units, and the time. Okay? So if you need to pause the video, write down that sentence, and then you can go ahead and move along. I did the same thing for part B, again, just to save time in the video. So pause if you need to and copy down the sentence because you need to have all the parts there. So now we're talking about R of t represents the rate at which water drains from a tank. So now we're doing an integral of a rate. This is what we just did in Unit 7. All right, so this one should be a little bit easier to understand. So the integral from 1 to 8 of R of t dt represents, here's your noun, it's the amount of water drained from the tank. What are we measuring it in? We're measuring it in liters. And again, you can kind of manipulate the stuff there and actually find the area and see that the liters work out. And then when are we doing it? Well, this one is an integral, which means the time is over an interval. And it's from t equals 1 to t equals 8 hours. All right, so it's always got these three pieces to your explanation. Again, if you need to pause the video to actually copy down the sentences, you need to do that because this should be part of your notes. Okay, now we're going to actually get into the new stuff here. So now we're talking about average value. So you'll notice your learning target is up here. All right, I can use a definite integral to find the average value of a continuous function over an interval. So let's talk about what average value actually means. We can think about it two different ways. Here's more of a visual way, and then we're going to talk about it in terms of words. So if we think about this gray shaded area here, this is clearly the area under the curve. So we're going to go ahead and call this A, we're going to call this B. So the shaded area there is the integral from A to B of whatever this function is. We're going to just call it f of x dx. All right, so when we find the average value, we're trying to find the y value that explains where a function would level off if we were to spread its area out equally. So in other words, if we were to take this area and try to make a rectangle, it would all end up falling underneath this y value right here. That's our average value. And so what that means, it kind of makes sense. If we take a look at this part here that's above the average value, it fits really nicely down here. And then it makes this nice rectangle that we can then talk about. Okay, that's what's happening visually. So then we can talk about it in terms of words and in terms of things that you guys already know, right? To find an average of a set of data, you add all the values and divide by the number of values that you have. If you want to find your average test score, you add them all up and you divide by how many tests you've had. You guys have done that before. But those are for discrete things. When we look at the data that's continuous or when it's connected, we can't just add the numbers. In this case, we have to actually use an integral to add up all the numbers instead. So if we think about it, we actually already said this gray area here is an integral. So if we wanted to add up all the values, right, we're not really adding them up, but in theory, that's what we're doing. So it's a to b of f of x dx. That's kind of like taking all your test scores and adding them up. And then dividing by the number of tests that you've had, which means dividing by what's the distance between a and b. Well, that would just be b minus a. Now, we don't normally write our average value that way, but I wanted you guys to kind of see where it's coming from. This is adding all the stuff up and dividing by all the number of things that you have. All right, now normally it's written this way. It's 1 over b minus a times the integral from a to b of f of x dx. So instead of dividing the integral by b minus a, we just take it and put it out front. But this is going to be really important as we move forward. All right, so let's talk about how to actually use this formula. So find the average value of the function. Here's your f of x, here's our interval. So this is a to b. So we can start out by doing 1 over b minus a. So it's 2 minus negative 1 times the integral from negative 1 to 2 of 1 plus x squared dx. So I'm going to start out by simplifying this. So 1 over 3 and then I'm going to take the antiderivative. So the antiderivative would be x plus 1/3 x cubed plus c, and I'm evaluating from -1 to 2. Alright, so then let's see. I'm going to get my 1/3 is just going to chill out front, and I'm going to plug in 2. So I'm going to have 2 plus 8/3 plus c minus, now I'm going to plug in -1. So -1 minus 1/3 plus c. So again, all I did is plug 2 into my function, and that's right here. Plug -1 into my function, and that's what I get right here. So I get 1/3 of, let's see, 2 plus 8/3. I know my c's are going to cancel, and I get plus 1 plus 1/3. And so we've got 1/3 of, let's see, that becomes 3. 8/3 plus 1/3 is 9/3, which is also 3. So 3 plus 3 is 6. So my average value is 1/3 of 6, which is 2. And there we go. I know I went through that arithmetic kind of fast, but I think you guys can handle it. Alright, looking at number 2, it says the average value of a function over the interval from -1 to 2 is 4. So average value from -1 to 2 is -4. Then it says that the average value of f over the interval from 2 to 7 is 8. And we're trying to find the average value over the interval from -1 to 7. Well, if we look, we have the average value from -1 to 2 and the average value from 2 to 7. So I think we could probably get to -1 to 7 pretty quickly. So I'm going to start by actually writing this information out. So the average value I know is 1 over b minus a. So 2 minus -1 times the integral from -1 to 2 of f of x dx, and I know that that's equal to -4. So I'm going to start out by simplifying that. That becomes 1/3 times the integral from -1 to 2 of f of x dx equals -4. So that's my first piece of information. The second piece says the average value from 2 to 7 is 8. So the average value is 1 over 7 minus 2 times the integral from 2 to 7 of f of x dx, and that's equal to 8. So that means 1 over 5 times the integral from 2 to 7 of f of x dx is equal to 8. So now I have to think about how this information helps me. Well, I know that when I have integrals, if I have the integral from -1 to 2 and the integral from 2 to 7, I'd be able to get the integral from -1 to 7, right? My end goal here is to be able to figure out 1 over 7 minus -1 times the integral from -1 to 7 of f of x dx. So in other words, 1 over 8 times the integral from -1 to 7 of f of x dx. So if I could figure out what the integral from -1 to 7 of f of x dx is, I'd have my answer. So we're going to manipulate these average values just a little bit more. This says that 1/3 of this integral is -4. So if I multiply both sides by 3, I get that the integral from -1 to 2 of f of x dx is equal to -12. If I look at this one, this says 1/5 of the integral from 2 to 7 is 8. So I'm going to go ahead and multiply both sides by 5, and I get that the integral from 2 to 7 of f of x dx is equal to 40. So that must mean that the integral from -1 to 7 is equal to, of f of x, my bad, dx, is equal to the integral from -1 to 2, which is -12, plus the integral from 2 to 7, which is 40. And so if I add those up, what do I get? 28? Does that sound right? Yeah, 28. So that means I can put that in here. So my average value is 1/8 of that integral, so 1/8 of 28. And if we simplify that down, those are both, let's see, that becomes 28 over 8, right? Which then I can divide both of those by 4, and I get 7 over 2. I know my work was kind of all over the place there, so I hope you guys were able to follow along with it. But really what I did is I took the average values that they gave me and I turned them into just plain old integrals so that I could find the integral that I was looking for the average value of, because then I just had to divide that by the distance. Okay? All right. Question 3. You can see this is a calculator question, so please make sure you grab your calculator. You need it with you. All right, so we're talking in this problem about the average, we're talking about the temperature in degrees Fahrenheit over 24 hours, and it's given by this formula. All right, so part A, these 3 questions are going to be really important. We have to talk about the difference between them. So part A says, what's the average rate of change over the 24-hour time period? So the thing we have to remind ourselves is that a rate of change means we're looking at a slope. And we're looking at a slope from 0 to 24, which means this is just our regular old slope. So we're going to do f of b minus f of a all over b minus a. Now we're not doing f, we're doing t because we're talking about temperature. All right, so what that means is find the temperature at 24 hours, find the temperature at 0 hours, and we're going to actually find the slope. So again, because it's average rate of change, it's this rate of change over an interval, this is just regular old slope. This is not calculus, okay? So now we're going to go ahead and use our calculator here. So let's see, if I plug in, I'm going to plug in 24, so 70 plus the sine of 24 over 2 minus 24 over 2, and I get 57.463. And then if I plug in 0, I get 70 plus the sine of 0 minus 0, so whatever. And I could have done that in my head, but I'm just showing you guys how to quickly get through this problem over 24. All right, so now I'm going to find out what that is. So 57.463 minus 70 all over 24. And we get that the average rate of change is going to be negative 0.522. Now we need to talk about what those units actually are. So if we think about it, because we're finding the slope, we know that on top we were finding the temperature, which is degrees Fahrenheit. And on the bottom, we were talking about from B to A. We did from 24 hours to 0 hours. So this was in hours, which means our units for this are in degrees Fahrenheit per hour, which should make sense because, again, we're talking about a rate of change. So your units should reflect that it's a rate of change. Now notice, I just taught you average value on the last page, and this talked about the word average, but it was not average value. All right? So you have to be careful. Just because it says average doesn't mean that you're always going to be using that average value formula. Okay, part B says what is the rate of change of the temperature at t equals 4. So now we're doing a rate of change, but now it's at a specific point. So this is still a slope, but because it's at a specific point, we know that this is going to be a derivative. So this question is really asking you to find t prime of 4. So what we're going to do is we're going to go ahead and we can put our function into y equals. So 70 plus 2 times the sine of x over 2 minus x over 2. And by the way, we could have put this in our calculator to get the 24 and just gone to the table, but regardless, make sure that it's plugged in correctly because we're going to use this for parts B and C. So I think I'm good. Okay. So to find a derivative, we know that we're going to do math 8. We're going to take the derivative with respect to x, and now we're going to try and get that y value in there, that y1. So click on variables, go over to y variables, it's a function, and it's y1. So there we go. We're going to take the derivative of y1 at x equals 4. So we get negative 0.916. And again, we need to talk about our units here. So since we're still talking about a rate of change, we're talking about degrees Fahrenheit per hour. The average rate of change is negative 0.916 degrees Fahrenheit per hour. Now part C is where we get into what we're actually talking about for this unit. So we're talking about the average temperature. The way that I know I'm doing average value is I want the average value of the function that I actually have. This function was all about the temperature. So now I'm going to go ahead and do my 1 over b minus a times the integral from a to b of, now I'm talking about temperature. Alright, so let's see, 1 over, it's a 24-hour period, so 24 minus 0 times the integral from 0 to 24 of t of t dt. Now I don't want to type in this whole function again. That's why we put it into that y variable. Alright, so I'm going to do 1 over 24 times the integral, so I'm going to do math 9 from 0 to 24 of, I need to put in that y variable. So again, variables, y variables, function y1. So we're going to find the integral from 0 to 24 with respect to x. We get that this average value then is 64.026. So now we need to talk about what this is. This one is asking us about the average temperature over the 24-hour period. So that means we better have degrees Fahrenheit as our units because that's the average temperature. Now the reason that this makes sense is because if we look at our, I'm going to go to this one, if we look at our actual thing here, our formula, that's the word I was looking for, 1 over b minus a is talking about, in terms of units, it's 1 over hours. And if we look at what the integral is, we know that the integral is taking the temperature, which is in degrees Fahrenheit, and multiplying by hours. And so the hours cancel out and we get our degrees Fahrenheit back. We want the average value of this function, so the units should work out to be the same as what the units of the original function were. Okay? There's 2 more things we have to talk about. I know it's getting a little long, so bear with me, okay? Alright, so C of t represents the daily cost of heating your house measured in dollars per day, where t is measured in days and t equals 0 corresponds to January 1st of 2010. So really the important part here, C of t is the daily cost of heating your house measured in dollars per day, and then time is measured in days. So if we want to interpret this first one here, it's 1 over 90 minus 0 times the integral from 0 to 90 of C of t dt. This is that average value that we were just talking about. Alright, so if we want to look at interpreting what this actually means, remember we need 3 things. We need the noun, the units, and the time. So if we think about what this thing actually represents, it represents the average cost. Hold on, sorry, my bad. I just got distracted. What do I want? Blue, orange, purple. Okay. Alright, so it represents the average daily cost of heating your house measured in dollars per day, because it's the same as the original function, since it's the average value of that original function. And then since it's an integral, we're talking about an interval, right? So it's over. And let's think about what this means in this context. Well, we're doing from 0 to 90, and we're talking about days. So instead of saying over, I think I'm actually going to say it's the average daily cost of heating your house measured in dollars per day for the first 90 days of 2010. Now we could say just over the interval from t equals 0 to t equals 90 days, but if we want to be more specific to what this problem actually talks about, we can write it that way. And again, I forgot to actually put the thing that we're talking about. So the integral from 0 to 90. So this thing represents the average daily cost of heating your house measured in dollars per day for the first 90 days of 2010. This isn't my best video, guys. Bear with me. Alright, so the last part says interpret 0 to 90 of C of t dt using units in the context of the problem. So this, we can see, is exactly like this, but without this 1 minus 90. So the 1 over 90 minus 0. So that part there is what gets us to the average daily cost. This is a little different. We have to remember that C of t is a rate. So if we're doing the integral of a rate, then we're going to end up getting an amount of something. So the integral from 0 to 90 of C of t dt represents the total cost of heating your house. And now if we're talking about cost, that's going to be measured in dollars. And we're still talking about an interval, right? So we could still just say that last part's the same. So for the first 90 days. Of 2010. Alright, so again, this is very similar to what we did in Chapter 7, so hopefully interpreting that integral was fine. But you really need to make sure you understand the difference between this one, which is the average value of the cost, and this one, which is going to give us the total cost. Okay? Alright, I know that this was long. Thank you for bearing with me. Sorry about all the mistakes I made. I will see you guys in class for some practice.